Welcome to another video. So this is thermochemistry. So under this thermochemistry, we want to solve a question under calorimetry. So before I solve the question, what is calorimetry? Calorimetry is the science that deals with the study of change of states of a substance as a result of heat transfer. So that is calorimetry. Now, what is enthalpy? Enthalpy is the heat content of a chemical system. That is enthalpy. So when we now say enthalpy of combustion, let's give the definition of enthalpy of combustion. Enthalpy of combustion is the amount of heat evolved when 1 mole of a substance burns completely in oxygen to liberate energy. So we have two types of reaction in thermochemistry. We have the exothermic reaction and we have the endothermic reaction. In endothermic reaction, heat is absorbed from the environment, and exothermic reaction, heat is liberated or evolved to the environment. So enthalpy of combustion is the amount of heat evolved when 1 mole of a substance is burnt completely in air or in oxygen. Now the question goes thus: the heat liberated in the combustion of 1.2 gram of magnesium is used to raise the temperature of 500 cm³ of water by 7 degrees Celsius. Calculate the enthalpy change for the combustion of magnesium in kilojoule per mole. Now, the atomic mass of magnesium is 24. Density of water is 1 gram per cm³. Specific heat capacity of water is 4.2 joules per gram per Celsius. Now, the solution. So the first thing we are going to do is to write out the parameters. So let's write down the parameters. Now, the density of water, O of H2O, is equal to 1 gram per cm³. Then the specific heat capacity of water, SHC of water, specific heat capacity, is equal to 4.2 gram joules per gram per Celsius. Then what other factors, what other constants? Then we're given the volume of water. The volume of water is equal to 500 cm³. Okay? Then the change in temperature, delta theta, is equal to 7 degrees Celsius. Then the mass of magnesium is equal to 1.2 gram. So that is the mass of magnesium. So now, the next line of action is to calculate the heat gained by water. Then the heat gained by water, we know that Q is equal to MC delta theta. So that is Q. Q is equal to MC delta theta. Because we know that specific heat capacity can be defined as the quantity of heat required to raise the temperature of a unit mass of a substance by 1 degree Celsius or 1 Kelvin. That is the definition of specific heat capacity of water. So we need to find the heat gained by water. So this expression is heat gained by water. So now we knew that Q is equal to MC delta theta. Now from the context, the mass of the substance is 1.2, then multiplied by the specific heat capacity of the substance is 4.2. Then change in temperature. Okay, the mass of the substance is not 1.2. What we are going to do now is to change this volume we change this because the mass here is the mass of magnesium. So we need to calculate the mass of water. So we can't use the mass of magnesium here. So we need to calculate the mass of water. So volume from the formula of density equal to mass over volume. So from this context, we can easily calculate the mass of water. So mass of H2O is equal to rho V. That is the density times volume. So mass of water is equal to mass of H2O is equal to, then the density of water from the context is given to us as 1 gram per cm cube. Then multiplied by the volume of water here is 500 cm cube. So when we put them together, 1 times 500, that is 500 grams. So mass of water, our M here is 500. Then multiply by, now the change in temperature is 7 degrees Celsius. So that is 7. Then Q is equal to, now when we compute this, the multiplication of this should give us 14,700 joule. So when we multiply this by this, the quantity of heat required to burn 1.2 gram of magnesium is 14,700 joules. So we need to convert it back to kilojoules. To convert it to kilojoule, you divide by 1,000. So Q is equal to 14.7 kilojoule. So now we need to analyze. So how do we analyze? Now that implies that 1.2 gram of magnesium liberates 14.7 kilojoule of heat when it combusts. So that means this 1.2 gram of magnesium produces this amount of heat. Now, according to what I said earlier on, from Adam I said the enthalpy of combustion is the amount of heat evolved when 1 mole of a substance is completely burnt in air or in oxygen. And 1 mole of magnesium, the mass of 1 mole of magnesium is 24 gram per mole. So that 1 mole is 24 gram. Hence, 24 gram of magnesium will liberate X amount of heat. So we need to find the unknown X. So when you cross multiply, this crosses this, this crosses this. X times 1.2, that is 1.2 X is equal to 14.7 times 24. So we make X the subject of the relation. So how do we go about that? So we divide both sides by 1.2 over 1.2. So the next line of action is to do the division. Then 1.2, how many 1.2 can we see here? 1.2 here 1, 1.2 here, that is 20. So we need to multiply this by 20. So when we multiply this by 20, X is equal to 294 kilojoule. 294 kilojoule. So now, the question now goes thus. The heat liberated in the combustion of 1.2 gram of magnesium is used to raise the temperature of 500 cm cube of water by 7 degrees Celsius. Calculate the enthalpy change for the combustion of magnesium in kilojoule per mole. So 294 kilojoule per mole. So now, we are now going to analyze to write our results. So what is the analysis? So the question says, calculate the enthalpy change for the combustion of magnesium. Hence, the enthalpy change for the combustion of magnesium is minus 294 kilojoule per mole. So that is the result. Now, someone can ask me a question that why are we putting minus? Because in our calculation there is no minus. Yes, that is a very good, it's a 1 million question begging for answers. So why are we putting negative? You remember vividly that exothermic because it is liberated to the environment. So anytime it is liberated to the environment, the enthalpy will be negative. The enthalpy is negative. So definitely it is what? It is evolved. So whenever it is evolved, the heat change will be negative. So that is the reason we are having negative as our result. So hence the enthalpy change for the combustion of magnesium is minus 294 kilojoule per mole. So that is the end of today's class. Life is always continuous, life is differentiable, life is integrable, but not the best measuring. It is a diet.